let's work on the exponential equation that you see on your screen. The first thing that we can see here is that the equation doesn't have any constants. So this means that we are ready to proceed to the next step. No constants, no coefficients, so there is no need for any cleanup here. What is strange is that we have two powers, but each one has a different base. So usually what we do is that we select the power that has the simplest exponent. Right here the exponents are very similar. There are no complicated linear expressions in the exponents, so I can use any one of those. Let's use the number 2. Let's use as our base the number 2. The next step that I need to take is to take a log, the logs from both sides of the equation with base 2. Since 2 to the x plus 1 is equal to 3 to the x minus 4, then this means that the logarithms of those two will be equal as well. So I take the log right here from both sides, and remember that we need to have the same base, and I have chosen the number 2. Again, you can choose any of the two. Usually it works better if you use the one that has the simplest exponent. Okay, so I take log with base 2 of 2 plus x plus 1 is equal to the log with base 2 of 3 to the x minus 4. And next step is to use some of the logarithmic properties that I know that can help me to simplify that. The first one that I know is the power rule. The power rule says that if I have the log with base a of x to the k, this is nothing else than k times log with base a of x. So this is the one that I will use for both sides of my equation, since I have powers on both sides. So now I get x plus 1 here on the left side. Remember to put it in parentheses to avoid issues when you distribute. Log with base 2 of 2 is equal to x minus 4 on the right side times log with base 2 of 3. Okay, now another property that I can use is the property that tells me that if I have a logarithm of base a of a, this is going to be equal to 1, and this is the case right here. This is equal to 1. So I can cancel this out and replace it with 1, and this means that on the left side I have x plus 1, and this is equal to x minus 4 in parentheses. But unfortunately right here the base is 2 and the argument is 3, so this property doesn't apply here, so I need to leave it as is. So now I'm close to my solution, but still I haven't managed to get rid of all the logarithms, and sometimes this is not possible, as in this case. So what's the next step? The next step is to use distributivity in order to make sure that I don't have any parentheses. So I do not get rid of all the parentheses. And in order to get rid of the parentheses here, what you need to do is to apply distributivity. And this is going to be x times log with base 2 of 3 minus 4 times log with base 2 of 3 again. Now remember, I need to do that. I need to distribute the log to both terms inside my parentheses. The reason for that is because I want now to separate the variable terms that I have in my equation, that is the x and the x times log with base 2 of 3, from my constant terms that I see in my equation, and this is the number 1 and the number negative 4 times log with base 2 of 3. Now you will tell me, what is this? Why is this a number? Well, remember, log with base 2 of 3 is nothing else than a simple number. And actually it's a number that is less than 2, is somewhere in between 1 and 2, probably around 1.52. So if you multiply 4 times 1.52, you will get something like 6.4, 6.3. So that's a number, that's a constant. And this time, what I need to do is separate the constants from the variables. So I'm going to move these to the left side of the equation, and I will move the one to the right side of the equation. This way I will have on the one side, on the left side, the variable terms, and on the right side I am going to keep my constants. Now remember one thing, in order to move the terms from the one side of the equation to the other side of the equation, you need to change the sign, so don't forget that. So this is what I have up to that point, and as you can see, I have x minus x times log with base 2 of 3. Am I ready to solve the equation? Well, the issue here is that I have two terms with x. And in order to solve for x, I need to have only one term with x right here. So in order to do that, what I'm going to do is to factor out the GCF. So I'm going to look for the GCF on the left side. And the GCF on the left side is the number x. So now I have x times 1 minus log with base 2 of 3. And this is equal to negative 4 times log with base 2 of 3 minus 1. So now I'm ready. And why now I'm ready? Because I have only one term right here on the left side of the equation, x times something. It doesn't matter what is this something, it's something. And this is going to be nothing else than the coefficient. So I'm ready to divide both sides by this coefficient. And I can simplify the coefficient on the left side, so this is equal to x. And this is the solution of this equation. Let's solve now a different equation, a little bit more complicated. Again, what I observe is that I have right here a power, I have a coefficient to that power, and I have two constants. So the first step that I need to take in order to isolate my power is to move the constants on the right side of the equation. So I will have now 4 times e to the 2x minus 7 minus 13 equals to 3. And in order to move this constant to the right side, I need to add to both sides the number 13. This will allow me to cancel now. Negative 13 plus 13 is equal to 0. So at the next step, I have 4 e to the 2x minus 7 is equal to 16. Now I have on the one side of the equation, I have no constants, and this is good. So now at the next step, what I need to do is get rid of the coefficient of the power. That's your power, that's the coefficient. And in order to do that, I have to divide by it. So if I divide with my coefficient, then I manage to simplify the 4 and 4 on the left side, and I have e to the 2x minus 7 equals to 16 over 4 is equal to 4. Now I'm ready to solve using logarithms. The base of my power is e, so I'm going to take the log with base e, that is nothing else than the ln. So I will take ln from both sides of the equation. E to the 2x minus 7 equals to ln of 4. I will use, at this step, I can use the power rule that tells me that log with base a of x to the k is equal to the k times log with base a of x. So I can manage to move the k down next to the log. This has two effects, two side effects. The first is that I move the x from the power, from the exponent, down to the equation. And the next is that I will be left with ln of v, that the next rule, log with base a of logarithms, tells me that this is equal to 1. So 2x minus 7, from the power rule, I bring the exponent down here, and I have 2x minus 7 times ln of v equals to ln of 4. I do not touch the right side. And now, since ln of v has the base is e, the argument is e, this is equal to 1. It leaves me with 2x minus 7 equals to ln of 4. This is a number, some specific number. There are no x's here. This is a number, so I have two constants here. So the only variable term is this. So I can move now the 7 on the other side of the equation by adding 7 on both sides. This way I simplify, I cancel out negative 7 and plus 7. So I have 2x equals to ln of 4 plus 7. Remember, the argument of ln is just 4. The 7 is added to the ln of 4. And now I divide by the coefficient from both sides of the equation. So this gives me the final answer that x is equal to ln of 4, remember that's 1 plus 7 divided by 2. Use parentheses as much as you can to avoid confusing what is the argument of the logarithms and what is not. And that's the solution for this equation.